Imagine you are looking at a photograph of a sprawling city at night. You see the vibrant neon of the skyscrapers, the rhythmic pulse of headlights on the highway, and the warm glow of street lamps. To your eyes, the city is the light. But if you were to suddenly remove the steel beams, the concrete foundations, and the hidden electrical grid, the lights wouldn't just go out. They would fall. They would collapse into a meaningless heap of glass and wire. For 90 years, humanity has been staring at the lights of the universe, the stars, the nebulae, and the galaxies, completely oblivious to the fact that they are hanging on a skeleton we cannot see. We have called it dark matter, a humble placeholder for our own ignorance. We treated it like a ghostly mist, a passive passenger in the cosmic dance. But in November 2025, the silence finally broke. When we looked through the data from the Fermi telescope, we didn't just find a signal, we found the blueprint. We finally saw how dark matter really looks. And it isn't just a substance, it is an architecture. And what that architecture reveals is far more unsettling than a simple ghost in the machine. It suggests that the universe isn't just a place where things happen. It is a system that is being rendered. Most documentaries will tell you that dark matter is a mystery because we can't touch it. But they miss the most terrifying part of the discovery, its efficiency. If you look at the cosmic web, the vast interconnected filaments of dark matter that stretch across billions of light years, you aren't looking at a random distribution of gas or a chaotic cloud of particles. You are looking at a structure that is mathematically perfect. In the world of computer science, we have a term for this kind of structural efficiency. It's called a hardware optimization. Think about the most advanced video game you've ever played. As you move through the world, the trees, the mountains, and the characters appear in stunning detail. But behind that beauty, there is a rendering system. There is a computational framework that dictates exactly where every asset should be placed to ensure the world doesn't collapse under its own weight. This is the hardware problem that the scientific community is only just beginning to whisper about. While the outlier videos you've seen focus on dark matter as a ghostly substance, they ignore the fact that it acts as the universe's ultimate rendering system. It is the scaffolding that tells ordinary matter where to go and how to behave. If dark matter were merely matter, just another particle like a proton or an electron, it would be messy, it would clump, it would collide, and it would react to the environment around it. But dark matter is different. It is non-reactive, non-illuminated, and seemingly indifferent to the laws that govern the visible world. It accounts for 85% of everything that exists, yet it refuses to participate in the software of the universe, the light, the heat, and the chemistry that we call reality. This has led to a radical shift in our understanding. What if dark matter doesn't interact with light, because light is part of the asset layer, while dark matter is the hardware layer? In a simulation, a character made of pixels can interact with a sword made of pixels, but neither can ever touch the motherboard or the silicon chips that are making the entire experience possible. The reason we have struggled to see dark matter for nearly a century is that we've been trying to find a character in the game when we should have been looking for the code. When we examine the massive filaments of the cosmic web, we see that they are not just bridges between galaxies, they are the most efficient pathways for the flow of information and mass. They are the universal bus lines of a cosmic supercomputer. This isn't just a metaphor, it's a structural reality. The way these dark filaments connect clusters of galaxies mirrors the way neural networks in a brain or fiber optic cables in a global network are arranged to minimize latency and maximize connectivity. If the universe were a random explosion of matter, we would see a chaotic distribution. Instead, we see a perfectly optimized grid. This is the hardware problem. The scaffolding is too perfect to be an accident. It suggests that the dark matter web is the computational framework of the universe, a pre-existing grid that was laid down before the first star ever sparked into existence. This realization changes the way we interpret the invisible skeleton. We aren't just living in a universe that contains dark matter. We are living inside a structure that was built by it. Ordinary matter, the stuff that makes up your body, your home, and your planet, is merely the illuminated decoration on top of this massive, hidden foundation. We are the glowing moss, growing on the stones of a cathedral we didn't know was there. If you were to remove the dark matter tonight, the galaxies wouldn't just drift apart. The very rendering of our reality would cease. The stars would unravel, because the gravitational code that keeps them bound would be deleted. This is why the hunt for a specific particle, like a WIMP or an axion, has felt so frustratingly empty for decades. We've been looking for a single brick when the evidence suggests we are standing inside the wall itself. The mystery whispered by the stars in their strange, fast-moving orbits isn't just that there is more mass, it's that the mass is distributed with a foresight that defies traditional physics. When we observe the weight of the unseen, we are seeing the gravitational footprint of the hardware. The reason dark matter doesn't reflect light or absorb it is simple: it doesn't need to. In a rendering system, the scaffolding isn't meant to be seen by the users, it is only meant to support the environment. This takes the hidden dimension theory and grounds it in a terrifyingly modern context. Perhaps the reason gravity seems to leak into our world is that it is the only force capable of bridging the gap between the hardware of the simulation and the software of our perception. By shifting our focus from what is it to what is it doing, we begin to see a universe that is far more organized and perhaps far more intentional than we ever dared to imagine. We have spent 90 years thinking we were the main characters in a grand cosmic story, only to realize that we are just the light FX playing on the surface of a much deeper, much darker machine. The structural efficiency of the cosmic web is the smoking gun. It is the proof that the universe isn't just a collection of things, but a calculated system. And as we peel back the layers of the invisible, we are forced to confront an existential truth that the scientific transcripts usually leave out. The more we see of the hardware, the more we realize that humanity understands almost nothing about the true nature of our home. We are guests in a house where the walls are invisible, the floor is made of shadows, and the architect has left us no manual. Only the silent, perfect pulse of a system that has been running since the dawn of time. Imagine you are standing on a high balcony, looking out over a sprawling metropolis in the dead of night. From this height, the city is nothing but a collection of lights, the neon hum of signs, the rhythmic pulse of headlights on the highway, and the warm golden squares of thousands of windows. To your eyes, the city is the light, and the darkness between the buildings is just an empty void, a canvas upon which the light is painted. But if you were to suddenly remove the steel beams, the concrete foundations, the subterranean pipes, and the hidden electrical grid, the lights wouldn't just go out, they would fall. The entire illuminated world would collapse into a meaningless heap of glass and wire, because the structure that held them in place, the unseen skeleton of the city, is gone. For 90 years, humanity has been staring at the lights of the universe, the stars, the nebulae, and the galaxies, completely oblivious to the fact that they are hanging on a skeleton we cannot see. We have called it dark matter, a humble placeholder for our own ignorance, treating it like a ghostly mist or a passive passenger in the cosmic dance. But as we peel back the layers of reality, we are beginning to realize that we have fundamentally misunderstood the role of this invisible majority. We finally saw how dark matter really looks, and it isn't just a substance. It is an architecture, a computational framework that dictates the very existence of everything we have ever known. The competitor transcripts you might have seen focus on the history of discovery, the eccentric Fritz Zwicky in 1933, or the pioneering Vera Rubin in the 1970s. And their hunt for a specific particle like a WIMP or an axion, they treat dark matter as a missing mass problem, a ghost that simply adds weight to the universe. But this ghostly narrative ignores the most startling realization of modern cosmology: the hardware problem. While the scientific world focuses on what dark matter is, they are missing what it is doing. If dark matter accounts for 85% of all matter in the universe, then everything we see, every star, planet, and person, is just a thin layer of illuminated decoration on top of a far larger, hidden structure. Dark matter acts as a cosmic scaffolding, a framework that ordinary matter settles into as stars and gas accumulate over billions of years. But look closer at that scaffolding, and you see something that defies the chaos of a random explosion. You see the cosmic web, a vast, interconnected network of filaments and voids that spans the entire observable universe. This structure isn't just a random distribution of mass, it is a system of terrifying structural efficiency. In the world of computer science, we have a term for this kind of optimized efficiency. It is a hardware architecture. Think about the most advanced virtual reality simulation you can imagine. As a player moves through the world, the environment, the trees, the mountains, the characters appears in stunning detail. But behind the beauty of the assets lies the rendering system. There is an underlying computational framework that dictates exactly where every object should be placed to ensure the world doesn't collapse under its own weight. This is the hardware problem. We have spent a century trying to find a character in the game, a particle we can touch, when we should have been looking for the code. The reason dark matter doesn't interact with light, doesn't reflect it, and doesn't cast a shadow is that it isn't part of the software of our reality. It is the motherboard. It is the silicon chips upon which the program of the universe is being rendered. This is why dark matter doesn't clump into stars or form planets. Its job isn't to be stuff. Its job is to be the grid. It provides the gravitational landscape that tells ordinary matter where to go and how to behave. When we examine the massive filaments of the cosmic web, we see that they are not just bridges between galaxies, they are the most efficient pathways for the flow of mass and information across the cosmos. This isn't just a poetic metaphor, it is a structural reality revealed by our most advanced simulations. When scientists attempt to recreate the universe using only the matter we can see, the results are a chaotic mess. Galaxies never form, and the large-scale patterns of the universe never emerge. But when you add the dark component, the invisible framework, the universe assembles itself with mathematical perfection. The dark matter web forms first, creating long threads and dense nodes that act as gravitational wells. Only then does ordinary gas cool and settle into these pre-existing wells to become stars. The hardware was laid down at the dawn of time, and we are simply the light FX playing on its surface. This suggests that the universe isn't just a collection of objects floating in a void. It is a calculated system, a rendering that requires a massive, unseen foundation to function. We have struggled to see this foundation because we have been looking through the wrong lens. Our eyes evolved to detect light, to survive on a planet where light is the primary carrier of information. But light is a minority player in the cosmic budget. Gravity is the true language of the universe, and gravity is patient. Gravity doesn't care about visibility, it only cares about mass. Through gravitational lensing, we have finally begun to see the wireframe of our reality. By watching how the invisible mass of dark matter warps and bends the light of distant galaxies, like a cosmic funhouse mirror, astronomers have been able to map the shadows of the cosmic web. These maps reveal that dark matter isn't just there, it is organized into a network that looks startlingly familiar. The way the dark filaments connect clusters of galaxies mirrors the way neural networks in a brain or fiber optic cables in a global network are arranged to minimize latency and maximize connectivity. If the universe were a random explosion, we would see a chaotic distribution of matter. Instead, we see an optimized grid. This raises an existential question that the scientific transcripts usually avoid. Why is the scaffolding so perfect? If dark matter acts as the computational framework of the universe, does that mean the universe itself is a form of cosmic intelligence, or perhaps a simulation running on a hardware we are not meant to perceive? This is the hardware problem in its most terrifying form. It implies that the laws of physics we have spent centuries mastering, the laws of light, heat, and chemistry, are merely the user interface of a much deeper machine. We are like characters in a video game who have finally discovered the pixels, but still haven't realized we are running on a server. Competitors focus on the ghostly nature of dark matter because it makes for a good ghost story. But the truth is far more clinical and far more profound. Dark matter is not a ghost. It is the machine. It is the silent operator that has been running in the background since the Big Bang, ensuring that the galaxies stay bound and the stars stay lit. Without this invisible architecture, the universe would unravel, galaxy clusters would scatter, and the intricate web of reality would dissolve into nothingness. We are guests in a house where the walls are invisible, the floor is made of shadows, and the architect left no manual. Only the silent, perfect pulse of a system that has been running for 13.8 billion years. As we map the cosmic web and look into the heart of the hardware, we aren't just making a scientific discovery. We are catching a glimpse of the code that makes our existence possible, a reminder that humanity understands almost nothing about the true nature of its home. The hardware problem suggests that the reason we haven't found a particle is that the particle isn't the point, the structure is. If dark matter is the rendering system of the universe, then searching for a single WIMP or axion is like taking a magnifying glass to a computer screen and hoping to find the internet. You will find pixels, but you will miss the network. This realization changes the weight of the unseen. It transforms the empty spaces between the stars into a crowded landscape of influence and calculation. It tells us that the darkness isn't a void, it is a presence, a quiet, unspoken dance where the visible steps only make sense because of the steady pull of the machinery beneath them. We are finally seeing how dark matter really looks, and it looks like a system that was built for us, even if it has no interest in being known by us. The universe has a hidden skeleton, and it is finally coming into focus. But as the wireframe of reality emerges, we must ask ourselves, if we are just the illuminated decoration on top of the machine, what happens when the program finally reaches its conclusion? The machine doesn't need to speak to us, it only needs to keep rendering, and we are merely the light that follows the path it has already laid down. If you were to take a high-resolution map of the universe, a snapshot of the cosmic web that spans billions of light years, and place it directly next to a microscopic image of a human neuron, your brain would experience a moment of profound, unsettling recognition. The two images are, for all practical purposes, identical. You would see the same spindly filaments stretching across the darkness, the same dense clusters of activity where those filaments meet, and the same vast, empty voids separating the structures. For decades, the scientific community has treated this similarity as a curious coincidence, a mere byproduct of how gravity pulls matter into its most efficient configuration. But as we finally begin to see how dark matter really looks, we are forced to confront a question that the standard transcripts have completely ignored. If the skeleton of the universe looks like a brain, does it function like one? This is the biological parallel, the theory of cosmic intelligence, and it suggests that we aren't just living in a universe, we are living inside an organism. Most documentaries will tell you that the cosmic web formed because slight fluctuations in the early universe grew under the relentless pull of gravity. They will explain that dark matter, unaffected by radiation, began clustering first, creating long filaments and wide nodes that eventually pulled in the ordinary gas and dust to form galaxies. They describe this process as a mechanical, almost industrial assembly of mass. But this mechanical view fails to explain the startling structural efficiency of the network. Dark matter doesn't just clump, it organizes. It forms a patterns of filaments and voids that mapped by modern surveys across billions of light years. These filaments are the most efficient pathways for the flow of mass and energy across the cosmos, connecting clusters of galaxies like beads on a wire. This isn't just stuff floating in space. It is an interconnected mass network where the halos around galaxies are linked to one another in a continuous, unbroken chain. When we look at the human brain, we see a system designed for the rapid transmission of information across a complex web of neurons. When we look at the cosmic web, we see a system designed for the rapid transmission of mass and gravitational influence across a complex web of dark matter filaments. In both systems, the nodes, the dense regions where the filaments intersect, are the centers of highest activity. In the brain, these are the synapses where processing occurs. In the universe, these are the massive galaxy clusters where thousands of galaxies are held together by a gravitational field mainly shaped by unseen material. If you were to observe the universe over billions of years, you would see it move. You would see galaxies flowing along these filaments toward the dense nodes, guided by the gravitational gradient created by the unseen mass. You would see clusters growing, merging and evolving in a way that looks less like a collision of rocks and more like the growth of a living system. The hardware problem we discussed previously suggested that dark matter is the rendering system of reality, but the biological parallel takes this a step further. It asks if the rendering itself has a purpose. If dark matter dictates where these filaments and nodes appear, and if those structures are the absolute foundation of everything that has ever emerged, then the invisible skeleton isn't just a frame, it's a nervous system. Ordinary matter, the stars and planets and people, are merely the bioluminescent markers flowing through the veins of a much larger entity. We are the glowing cells moving through a body that is 85% invisible to us. As scientists have noted, the visible universe is only a surface layer floating on a deeper, heavier foundation. This hidden majority moves through us, through our planets, and through our stars without resistance. Yet it exerts a quiet, undeniable presence that controls the motion of galaxies wider than our imagination. Think about the scale of this realization. A single neuron in your brain has no understanding of the thought it is helping to produce. It simply reacts to the signals it receives, performing its role within the network. In the same way, a galaxy like our Milky Way moves through the sea of something it will never touch, following a gravitational landscape it cannot see. We are part of a structure that connects clusters to one another, forming a network of mass that shapes the universe on scales beyond simple observation. The cosmic web is the backbone of reality, a distribution of mass that created the framework upon which the cosmic structure developed. It influenced everything from the spacing of galaxies to the formation of the first baby stars at the cosmic dawn. This leads to the most controversial law gap in the scientific transcripts, the possibility of a cosmic consciousness. If the universe is a self-organizing system that mirrors the structure of a brain, is it possible that the flow of galaxies along filaments is a form of cosmic information processing? The speed of this thought would be incomprehensibly slow to us, taking billions of years for a single signal to cross a filament. But on a cosmic timescale, the universe is a dynamic landscape filled with unseen structures guiding the visible world. The gaps between the filaments, the cosmic voids, aren't just empty space. They are essential parts of the structure, their sizes and shapes determined by how the dark matter gathered elsewhere. In a brain, the space between neurons is just as important as the neurons themselves for the integrity of the signal. In the universe, the voids define the boundaries of the filaments. Competitors focus on the weight of the unseen as a problem to be solved by finding a particle like a WIMP or an axion. They treat the discovery of a signal from the Fermi telescope as a cold case file about to be closed. But they are looking at the fingerprints and ignoring the hand. They see dark matter as a glue or a shroud, but they miss the fact that this glue has formed an intricate, web-like, distribution that matches simulations only when it is treated as the dominant organizing force. Without the unseen mass, the universe wouldn't just look different. It wouldn't have the dependable patterns that allow us to explore the visible part with confidence. This suggests that the universe has a blueprint or a design that is inherently biological in its complexity. The hidden skeleton hook isn't just about what holds us up. It's about what we are part of. Our senses were shaped for surviving on a small planet with trees and weather, not for perceiving the cosmic truth of a 13.8 billion-year-old organism. We are small, temporary flashes of light in a universe that is loaded with a quiet presence, a partner in a silent, unspoken dance where our visible steps only make sense because of the steady pull of the dark matter beneath us. We finally saw how dark matter really looks, not as a cloud, but as a network, not as a ghost, but as a brain. If this parallel is true, then the fate of the universe, whether it is gobbled up by dark matter or eventually fades into darkness, is not just a matter of physics, but a matter of cosmic life and death. The dark matter web is the primary agent guiding the flow of everything. It is the operator lurking in the shadows, the stagehand moving the props of reality behind the scenes. And as we look deeper into the intricate web-like distribution of the cosmos, we are forced to accept the most existential hook of all. Humanity understands almost nothing. We have found the neurons of the universe, but we are still centuries away from understanding the thought they are thinking. We are just beginning to see the face of the organism we inhabit. A reminder that the true structure of our home is invisible, dependable, and perhaps alive. Imagine you have spent nearly a century hunting for a ghost that doesn't want to be found. You have seen its footprints in the way galaxies spin too fast, and you have felt its cold breath in the way light bends around seemingly empty pockets of space. But the ghost itself has remained a phantom. For 90 years, the search for dark matter has been the ultimate cosmological cold case, a silent operator lurking in the shadows of everything we can see, making up 85% of the universe, while refusing to leave even a single fingerprint in our telescopes. We called it dark not because it is the colour of the night, but because it is utterly indifferent to light. It does not emit, reflect, or absorb it, making it effectively invisible to every tool humanity has ever built. But in November 2025, the silence finally broke. A researcher trawling through 15 years of archived data from the Fermi Gamma Ray Space Telescope discovered something that has rocked the scientific community to its core, a telltale signature coming from the very heart of our own Milky Way. We are no longer just measuring the ghost's weight through gravity. For the first time in history, we are seeing the glow of its annihilation. To understand why this discovery is so profound, we have to go back to 1933, to a Swiss astronomer named Fritz Zwicky, a man as famous for his eccentric personality as he was for his brilliant insights. While observing the Coma cluster of galaxies, Zwicky noticed something that defied the laws of physics as we knew them. The galaxies within the cluster were zooming around at speeds so high, over 2,000 kilometers per second, that the cluster should have ripped itself apart millions of years ago. According to the visible mass of the stars and gas, there simply wasn't enough gravity to hold the system together. Zwicky concluded that there must be something else at work, something dark and concealed from view that acted as a gravitational anchor. He was the first to realize that the universe is too heavy for the light it produces, a realization that transformed the cosmos from a tidy collection of stars into a mystery loaded with a quiet, invisible presence. For decades after Zwicky, we relied solely on this weight of the unseen to prove dark matter existed. We watched how stars on the outskirts of spiral galaxies refused to slow down, moving just as fast as those near the centre, as if they were being held in place by an invisible hand. We treated dark matter like a cosmic glue, an invisible shroud that wrapped around every galaxy in a massive spherical halo. It was the scaffolding that ordinary matter settled into, the gravitational foundation upon which the entire visible universe was built. Yet, despite knowing it was there, we were essentially blind men trying to describe a mountain by feeling the wind blowing around it. We could feel its influence, but we could never see its face. This is why the November 2025 reveal is such a turning point. The discovery by Dr. Tomonori Tatani at the University of Tokyo didn't come from a new telescope, but from a painstaking dredging of the Fermi telescope's back catalogue. The Fermi telescope is a piece of hardware designed to detect gamma rays, the most energetic form of light in the universe. Usually, the heart of our galaxy is a maelstrom of radiation, a blinding blizzard of signals coming from supernova remnants, pulsars, and the accretion disk of the supermassive black hole Sagittarius A. To find a signal from dark matter in that chaos is like trying to hear a single whisper in the middle of a jet engine's roar. But by blocking out the known astrophysical producers of gamma rays source by source, Dr. Tatani revealed a unique, ghostly pattern that matches the predicted shape of the Milky Way's dark matter halo. This signal is what scientists call a telltale signature, and it points directly to a class of particles known as WIMPs, or weakly interacting massive particles. According to the theory of supersymmetry, every particle has an antiparticle pair. When a particle meets its antimatter counterpart, they cancel each other out in a process called annihilation, releasing a signature burst of pure energy. If dark matter is made of WIMPs, these particles should occasionally collide with one another in the densest parts of the galaxy, producing a very specific glow of gamma rays. The energy spectrum of the signal found in the Fermi data peaks at 20 giga-electron-volts, a range that fits perfectly with what we would expect from the death throw of a dark matter particle. This changes the narrative of dark matter entirely. We are moving away from the era of invisible shadows and into the era of the invisible reveal. We aren't just looking at the gravitational effects of a ghost anymore. We are seeing the energy released when that ghost finally steps onto the stage. It is a revelation that suggests the invisible skeleton of our universe isn't just a passive frame, but a dynamic, active system. If this gamma-ray signal is indeed the glow of annihilation, it means we have captured the first direct evidence of the dominant form of matter in our existence. It is as if the universe's hidden hardware has finally flickered to life, showing us a glimpse of the motherboard that renders our reality. The implications are staggering. If dark matter can annihilate, it means it is part of a much larger and more complex family of particles than we ever imagined. It means that the 85% of reality we thought was missing has actually been right here all along, participating in a quiet, unspoken dance that we were simply too unevolved to perceive. We are finally seeing that the familiar world of stars and planets is just a thin layer of illuminated decoration on top of a far larger, hidden structure. This discovery doesn't just fill a gap in a textbook, it fundamentally changes the face of physics forever, bringing us closer to unifying the tiny world of particles with the vast expanse of the cosmos. However, as with any breakthrough that rocks the scientific community, we must err on the side of caution. While this signal is a strong contender for the smoking gun of dark matter, there are still questions about why the collection of WIMPs appears to be so much denser than our current models predicted. We have found a footprint, yes, but we are still identifying the creature that left it. The cold case of dark matter isn't closed yet, but for the first time in 90 years, the trail is hot. We have finally seen how dark matter really looks, and it looks like a flickering light in the darkness. A reminder that humanity understands almost nothing about the true nature of its home, but we are finally, at last, beginning to open our eyes. To understand the revelation of 2025, we have to travel back nearly a century to 1933, to a time when our map of the cosmos was still being drawn in pencil. At the centre of this story is Fritz Zwicky, a Swiss astronomer working at Caltech, who was as famous for his abrasive, eccentric personality as he was for his brilliant, often prophetic insights. Zwicky was a man who looked at the universe and saw things others missed, and in 1933 he pointed the Mount Wilson telescope toward a small patch of sky in the Coma Berenices constellation. He was looking at the Coma cluster, a massive family of thousands of galaxies bound together by the invisible threads of gravity. Zwicky wasn't just looking for beauty, he was measuring the redshift of these galaxies, a phenomenon where the light from a moving object stretches and turns redder, revealing how fast that object is travelling away from us. What he found that night didn't just puzzle him. It should have been impossible according to every law of physics humanity had ever written. As Zwicky sat at his desk, crunching the numbers from 8 of the cluster's galaxies, he realised they were zooming around at velocities exceeding 2,000 kilometers per second. To put that in perspective, at those speeds, the Coma cluster should have ripped itself limb from limb millions of years ago. Gravity is a direct result of mass. The more stuff there is, the stronger the pull. But when Zwicky calculated the mass of all the stars and gas he could see through his telescope, the figures didn't even come close to what was required to keep the cluster together. The system needed roughly 10 times more mass than was visible just to keep the galaxies from flying off into the dark void of intergalactic space. It was as if the universe was too heavy for its own good, possessed of a secret weight that refused to show itself to the light. Zwicky was the first to realize that the galaxies were being anchored by something hidden, something he dubbed dunkel materie, dark matter. For decades, the scientific community viewed Zwicky's discovery as an anomaly, perhaps a measurement error or a misunderstanding of distance. But as our tools improved, the weight of the unseen only grew heavier. In the 1970s, Vera Rubin observed that individual stars at the edges of spiral galaxies were moving just as fast as those near the centre, defying the expectation that they should slow down as they moved further from the galactic mass. This confirms Zwicky's nightmare. Every galaxy we look at is wrapped in a gigantic, invisible halo that provides the majority of its gravitational stability. We began to realise that the regular matter that makes up you, the planet beneath your feet, and every star in the sky is a minority portion of what truly exists. In fact, current estimates tell us that dark matter accounts for about 85% of all matter in the universe. Everything we have ever seen or touched is just a thin layer of illuminated decoration floating on top of a far larger, hidden structure. This is the 90-year shadow, the realization that the largest part of our reality has been missing for the entirety of modern human history. We are like people who have spent their lives admiring the intricate patterns of a spider's web while remaining completely blind to the spider that spun it. This missing 85% doesn't block light, it doesn't emit any, and it doesn't scatter it. It is truly invisible, yet it determines the entire shape of the cosmic performance. Without this unseen mass, galaxies wouldn't have formed in the first place, and the intricate, web-like distribution of the universe would simply fall apart. This weight is not a small correction to our equations. It is the dominant component of the cosmos, reaching across staggering distances to hold the very fabric of reality in place. When we weigh the universe today, we find the same consistency that Zwicky found in the 1930s. The visible components simply do not add up to the observed gravitational pull. No matter how many stars we count, or how deeply we peer into dust clouds, the extra mass continues to emerge as an absolute requirement. It is a persistent reminder that our senses are not shaped for cosmic truth, but for surviving on a small planet where everything we encounter responds to light. The weight of the unseen tells us that we are guests in a house where the walls are made of shadows we cannot perceive, but whose structural integrity allows us to exist. We have spent 90 years staring into that shadow, trying to understand a partner in a quiet, unspoken dance where the visible steps only make sense because of the steady pull of something beneath them. Zwicky's ghostly, transparent shroud has transitioned from a fringe theory into the fundamental backbone of our model of the universe. It has sculpted the cosmos to look the way it does today, influencing the motion of galaxies wider than our imagination. Yet, the mystery of its identity remains one of the greatest scientific challenges of modern civilization. We know the weight is there, we can measure it, map it, and see its fingerprints on everything that glows. But we still haven't found the source. As we move forward into the era of the invisible reveal, we must remember the man who first looked at a cluster of galaxies and dared to say that the most important part of the picture was the part he couldn't see. He established that 85% of reality is missing, leaving us to wonder what else is lurking in that 90-year shadow, waiting for us to finally find the light that can reveal its face. If you were to strip away every star, every planet, and every glowing nebula from the night sky, you wouldn't be left with a void. You would find yourself staring at the most massive structure in existence, a hidden skeleton. For decades, we treated the universe like a collection of isolated islands floating in an endless sea of nothingness. We looked at galaxies as lonely travelers drifting through the dark. But we were wrong. The universe has a body, and we have spent the last century only looking at its skin. The stars and the light they produce are merely the illuminated decoration on top of a far more complex, far more rigid foundation. This is the hidden skeleton of the cosmos, an invisible architecture that dictates where life can exist and where the dark must remain empty. We have finally reached a point where we can do more than just guess at its presence. We have mapped its bones, and what we found is that the universe isn't a cloud of gas. It is a web of interconnected pathways, a grid that was laid down before the first spark of light ever broke the silence of the Big Bang. The problem, of course, is how you map a skeleton that refuses to reflect even a single photon of light. You cannot shine a flashlight on the dark matter web. You cannot bounce a radio signal off its surface. To see the invisible, we had to stop looking at the dark matter itself and start looking at how it treats the light from everything else. This is where we use the most powerful natural tool in the universe, gravitational lensing. Imagine you are looking through a cosmic phonehouse mirror. When light from a galaxy billions of light years away travels toward Earth, it doesn't always move in a straight line. If that light passes near a massive concentration of dark matter, the gravity of that unseen mass warps the fabric of space itself. The light is forced to curve, to bend, and to stretch around the obstacle. When that light finally reaches our telescopes, the image of the distant galaxy appears distorted, magnified, or even multiplied into strange glowing arcs. By measuring exactly how that light is bent, astronomers can work backward to weigh the invisible lens that caused the distortion. This isn't just a mathematical trick. It is a way to trace the shadows of the unseen. Through these lensing maps, a startling image began to emerge. Dark matter wasn't just sitting in spherical halos around individual galaxies like a ghostly fog. Instead, it was stretched out into massive, elongated threads, dark filaments that connect one galaxy cluster to another across the staggering distances of the intergalactic void. We call this the cosmic web. It is an interconnected mass network that spans the entire observable universe, forming the backbone of reality. In our earlier search for dark matter, we were looking for stuff, a particle or a cloud. But the mapping reveals that dark matter is actually structure. It is a network of pathways that act like cosmic highways. Ordinary matter, the gas and dust that eventually become stars, is the passenger on these highways. It follows the gravitational gradient created by the dark filaments, flowing along the threads and gathering at the dense nodes where the filaments intersect. This realization destroys the old idea that the universe is a chaotic result of an explosion. If you look at the distribution of galaxies across billions of light years, they aren't scattered like sand on a beach. They are arranged like beads on a wire. These wires are the dark matter filaments, and they are the primary agent guiding the flow of everything we can see. When we observe the large-scale patterns of the universe, we are seeing the direct result of how dark matter clumped together shortly after the beginning of time. Because dark matter was unaffected by the radiation that kept ordinary matter from gathering in the early universe, it was able to begin forming structures much earlier. It created the gravitational wells, the seeds, into which visible matter would later fall. Without the hidden skeleton to provide this framework, the gas and dust of the early universe would never have gathered quickly enough to form the galaxies we live in today. The universe would be a thin, featureless soup of hydrogen, devoid of stars, devoid of structure, and devoid of us. Think about the scale of these filaments. A single thread of the cosmic web can stretch for hundreds of millions of light years. These aren't just bridges, they are the most efficient pathways for mass and energy in the cosmos. They define the boundaries of reality. Between these filaments lie the cosmic voids, vast, nearly empty regions of space where the dark matter web is spread thin. These voids aren't just empty space, they are the gaps between the bones of the universe. Their existence is just as important as the filaments themselves, because they dictate the flow of material toward the structures that will eventually become home to life. When we map these voids and filaments together, we see a universe that looks less like a void and more like a living, growing system. It is a structure that changes over time as gravity continues to draw material inward, making the filaments thicker and the voids larger. But there is a deeper, more unsettling mystery hidden in this map. Why does the skeleton of the universe follow such a precise, optimized distribution? In simulations, when we try to build a universe using only the matter we can see, the cosmic web never appears. The structures are too weak, too fragile, and they lack the intricate connectivity that we observe in the real sky. Only when we add the dark matter component does the universe assemble itself with mathematical perfection. This reinforces the idea that the invisible architecture isn't a byproduct of the universe, it is the source of it. We are the light FX playing on a stage that was built long before we arrived. The stars we admire are merely following the gravitational landscape that the dark matter web has already laid down. The mapping of these dark filaments has also revealed that dark matter doesn't behave like anything we have ever encountered in our laboratories. In systems like the Bullet Cluster, where two massive galaxy clusters have collided, we see the most compelling evidence of the skeleton's independence. When the clusters crashed into each other, the ordinary gas, the stuff that interacts with light, slammed together, heated up, and slowed down. But the gravitational lensing maps showed that the majority of the mass, the dark matter, sailed straight through the collision without slowing down at all. It didn't collide. It didn't react. It didn't feel the friction that ordinary matter feels. It simply moved forward, carrying the galaxies with it like a silent, unstoppable tide. This confirms that the skeleton isn't made of the same material as the skin. It is a fundamentally different form of matter, one that interacts only through the slow, patient pull of gravity. Every time we peer deeper into the cosmic web, the mystery only deepens. We have found the wireframe of our reality, but we still don't know what the wires are made of. We have mapped the hidden skeleton, but we don't know who the architect was. The consistency of these maps across every scale, from the rotation of a single dwarf galaxy to the vast lattice of the cosmic web, tells us that this influence is universal. It is the foundation that keeps the universe stable and dependable. But it is also a reminder of our own insignificance. We are temporary flashes of light in a universe that is dominated by a quiet, heavy presence that has been here since the dawn of time. We have finally seen how dark matter really looks, and it looks like a network that connects every corner of the cosmos in a silent, unspoken dance. We are moving through a sea of something we will never touch, following a path we didn't choose, in a house where the most important structures are the ones we can never see. Humanity understands almost nothing about the true nature of this home, but by mapping the skeleton, we have at least begun to realize that we are part of something much larger, much older, and much darker than we ever imagined. Imagine a world where everything you see is a lie, not a malicious deception, but a necessary one. Think about the last time you played a highly detailed video game. You walked through a dense forest, watched the sunlight filter through individual leaves, and felt the crunch of gravel beneath your character's feet. To you, that world was real. But if you were to look behind the curtain into the actual engine of the game, you wouldn't see trees or sunlight. You would see a wireframe. You would see millions of lines of code and a rigid mathematical architecture that dictates exactly how every pixel must behave. This is what we are starting to realize about the universe. For decades, we believed that the cosmos was a messy, chaotic result of an explosion, a random scattering of gas and dust that eventually clumped together by pure luck. But as we map the invisible structures of dark matter, we are finding a level of mathematical perfection that suggests we aren't looking at a natural occurrence. We are looking at a rendering system. This is the simulation glitch. The moment we realized that the invisible skeleton isn't just a frame, it's the underlying code of a rendered reality. The mystery begins with a simple observation. The universe is far too organized to be an accident. When astronomers use computer simulations to recreate the history of the cosmos, they encounter a massive problem. If you build a universe using only the matter we can see, the stars, the gas, the planets, the math simply stops working. The gravity of visible matter is too weak to pull things together in time. Without an extra, invisible ingredient, galaxies never form. They would be too small, too fragile, and they would lack the intricate, web-like distribution we see through our telescopes today. To make the universe work in a simulation, you have to add dark matter. But you can't just add it randomly. To match the real world, you have to distribute it with a precision that defies traditional physics. It has to be laid down first, forming a perfectly optimized grid of filaments and nodes, a scaffolding that exists before the first star is ever rendered. This is where the hardware problem becomes impossible to ignore. In any computational system, the rendering engine must be incredibly efficient to avoid crashing. The cosmic web, the vast network of dark matter that connects every galaxy cluster, is the ultimate example of this efficiency. It forms a structure that mirrors the most advanced neural networks or fiber optic grids, designed to minimize the latency of mass and energy flow across billions of light years. While other documentaries might call this a ghostly substance, that description is a distraction. Dark matter doesn't behave like a substance. It is non-reactive, non-illuminated, and seemingly indifferent to the laws of chemistry and radiation. It acts exactly like a set of back-end variables in a simulation. Variables that exist to influence the behavior of the assets, the TARs and PANA, without being visible to the users. Consider the process of galaxy formation. We used to think gas just clumped together until it became a star. But we now know that dark matter was the primary agent. It began clustering first, creating deep gravitational seeds or wells. These wells were placed with mathematical perfection throughout the early universe, acting as the designated spawn points for galaxies. Ordinary matter simply followed the cues set by this invisible architecture, settling into the pre-existing wells like water filling a pre-dug trench. If dark matter were merely a random particle, we would see variations, errors, or pockets of chaos. Instead, we see a universal consistency. No matter where we look, from the rotation of a tiny dwarf galaxy to the vast lattice of a supercluster, the ratio of dark matter to visible matter remains eerily stable. It is as if the universe has a default setting, a hard-coded instruction that dictates how much mass must exist to keep the simulation running. This leads us to the most unsettling question in all of cosmology. Is the universe calculating itself? If dark matter is the computational framework of the universe, then our entire reality might be the output of a rendering system we were never meant to perceive. In this framework, the reason we cannot see dark matter is not because we lack better telescopes, but because dark matter isn't part of the visual layer of reality. It is the motherboard. It is the silicon chips upon which the program is being run. We are like characters in a game who have finally discovered the pixels, but are still struggling to realize we are part of a program. Every star we see, and every planet we walk on, is just a thin layer of illuminated decoration on top of this massive, hidden machine. If you look at the weight of the unseen through this lens, the inconsistencies of the past 90 years suddenly make sense. The reason dark matter doesn't collide with itself or with us is that it exists on a different layer of the code. It passes through us without resistance because we are the software, and it is the hardware. This creates a relationship between visibility and truth that challenges everything we know. Our senses evolved to detect light so we could survive on a small planet, but the universe doesn't operate on light. It operates on mass and gravity. The dark matter web is the dependable part of the universe, the stable, invisible grid that ensures the stars stay bound and the galaxies don't unravel. But if reality is a rendered system, who is the observer? And what happens if the hardware fails? This is the core of the simulation glitch. We have spent nearly a century treating dark matter as a mystery to be solved, when in reality it might be the only thing keeping our reality from disappearing. We are finally seeing how dark matter really looks, and it looks like a blueprint. It looks like a system that was calculated, seeded, and rendered with a foresight that makes our own existence feel like a temporary flash in a much larger, much darker machine. We are guests in a house where the walls are invisible and the floor is made of shadows, a house that follows a mathematical perfection we are only just beginning to decode. As we peer into the cosmic web, we are forced to confront the ultimate existential hook. The more we understand the hardware, the more we realize that humanity understands almost nothing. We have found the code, but we are still a long way from understanding the mind that wrote it. We have spent nearly a century treating the universe like a cold case, hunting for a ghost that refuses to be caught on camera. We have felt its weight in the way galaxies spin and seen its fingerprints in the structure of the cosmic web, but we have never looked it in the face. For 90 years, the primary barrier was our own biological limitation. Our eyes evolved to detect light, yet 85% of reality is entirely indifferent to it. But astronomers eventually realized they didn't need to see the dark matter itself to map its existence. They only needed to see how it treated the light from everything else. This led to the discovery of the glass mirror, a phenomenon known as gravitational lensing, where the very fabric of space acts like a cosmic phone house mirror, warping and bending the light of distant stars into strange glowing arcs. This technique has allowed us to move beyond mere mathematics and finally see the invisible, providing the definitive proof that dark matter isn't just a placeholder in an equation, but a distinct, non-reactive entity that rules the cosmos. To understand how this mirror works, you have to imagine the universe as a vast sheet of fabric. Ordinarily, light travels across this fabric in a perfectly straight line. But Einstein's general relativity revealed that mass, any mass, acts like a heavy weight placed on that sheet. It creates a curve, a gravitational well that forces anything passing by to follow its bend. When light from a galaxy billions of light years away travels toward Earth and encounters a massive concentration of dark matter, it doesn't just pass through. It is forced to curve, stretch, and distort around the unseen obstacle. When that light finally hits our telescopes, the image of the distant galaxy is severely distorted, sometimes appearing as a ring, a magnified arc, or even a series of multiple identical reflections. This is the cosmic funhouse mirror in action. By measuring exactly how much that light is bent, we can work backward to weigh the invisible lens. We are tracing the shadows of the unseen, using the wireframe of the universe to prove that the hardware is there, even if it remains dark. This technique transformed the search for dark matter from a scavenger hunt into a mapping mission. We began to see that the universe is littered with these gravitational lenses, hundreds of them scattered across our skies. But while these maps showed us where the mass was, skeptics still argued that perhaps we weren't seeing an invisible substance at all. They proposed that maybe our understanding of gravity was simply wrong, and that gravity behaves differently on a massive scale than it does in our solar system. This is where the story of the bullet cluster changes everything. If the simulation architecture theory is correct, that dark matter is the hardware and ordinary matter is the software, then the bullet cluster is the ultimate proof of their separation. The bullet cluster is a cosmic car crash on a scale that defies imagination. Two massive galaxy clusters slamming into each other at millions of miles per hour. In a normal collision between two objects made of atoms, you expect friction. You expect a sticky interaction where things slow down and heat up. When these two clusters collided, that is exactly what happened to the ordinary gas. Using X-ray telescopes, we saw the gas clouds from both clusters slam together, compress, and become incredibly hot, creating a massive glowing pileup in the center of the collision zone. But when we looked through the glass mirror of gravitational lensing, we saw something that floored the scientific community. The majority of the mass didn't stop. The dark matter, acting as the invisible skeleton of the clusters, sailed straight through the collision as if the other cluster wasn't even there. It didn't slow down, it didn't heat up, and it didn't react to the sticky friction of the ordinary gas. The gravitational lensing maps showed that the mass had completely separated from the visible gas, moving ahead and carrying the galaxies with it like a silent, unstoppable tide. This was the smoking gun. It proved that dark matter is a distinct, non-reactive entity. If dark matter was just a trick of the light or a misunderstanding of gravity, the gravitational pull should have stayed with the gas, because that's where the matter was. Instead, the gravity followed the invisible. This separation provided the most compelling evidence yet for the hardware problem. It showed us that the hardware layer of the universe and the asset layer and Ra are not the same thing. In the bullet cluster, we watched the simulation's assets get caught in a bottleneck of physics, while the underlying architecture moved forward unimpeded. It revealed that dark matter doesn't just form smooth halos around galaxies. It exists as a fundamental, independent participant in the cosmic dance. It is the operator lurking in the shadows, a presence that moves through planets, stars, and even our own bodies without resistance, yet dictates the fate of entire clusters. The glass mirror has allowed us to confirm that the universe is not what it seems. We are living in a reality where the most influential structures are the ones we can never touch. Every time we see a distorted arc of light from a distant galaxy, we are looking at the gravitational footprint of a system that has been running for 13.8 billion years. A system that has no interest in being seen. The bullet cluster remains our clearest window into this truth, a reminder that the invisible skeleton is real, dependable, and far more powerful than the light. As we continue to map these shadows, we aren't just doing astronomy, we are decoding the very foundation of our home. We have finally seen how dark matter really looks, and it looks like a silent machine that has already decided where the stars will go, leaving us to simply follow the path it has already rendered. If everything we have discussed so far, the cosmic scaffolding, the mathematical rendering, the silent machine, feels like something out of a science fiction novel, it is because we are approaching the limit of what three-dimensional beings can comprehend. We have spent 90 years trying to find a particle in a box. But what if the reason we can't find the particle is that the box itself is just a thin, transparent layer floating on top of a much deeper reality? While most documentaries are content to describe dark matter as a ghostly substance that simply won't show its face, they fail to address the most provocative possibility of all, that the invisible skeleton isn't actually in our universe at all. Instead, what we are measuring is the higher dimension leap. This theory suggests that the gravitational weight we feel is merely the residue of matter existing in a parallel dimension, a realm right next door to ours that we are fundamentally unequipped to perceive. To understand this, you have to imagine the universe not as a vast three-dimensional void, but as a surface layer floating on a deeper, heavier foundation. Think of a single sheet of paper. To a two-dimensional creature living on that paper, the world is flat. They can move left, right, forward, and backward, but they have no concept of up or down. Now imagine you place a heavy lead weight just a fraction of a millimetre above that paper. The two-dimensional creature would never see the weight. They couldn't touch it, and their most advanced telescopes would reveal nothing but empty space. And yet, the paper would sag. The creature would feel a mysterious, invisible pull toward a central point, a ghostly gravity with no apparent source. This is the essence of the higher dimension leak. It proposes that the 85% of reality we call dark matter is actually ordinary matter, located in a fourth or fifth dimension, whose gravity is leaking into our three-dimensional slice of existence. This speculation offers the only elegant solution to one of the most frustrating puzzles in physics: why we can feel the weight of dark matter, but never touch its surface. If you walk through a cloud of dark matter, which according to current models you are doing right now, you feel absolutely nothing. It passes through your body, through the Earth, and through the stars without a single collision or a moment of resistance. For decades, we have assumed this is because dark matter is made of ghostly particles that simply don't like to interact. But the higher dimensional theory suggests a more startling reason. You can't touch dark matter for the same reason you can't touch a shadow. The bulk of its body is elsewhere. What we perceive as the cosmic web is not a 3D structure at all, but the three-dimensional cross-section of a much larger, higher dimensional entity. When we use gravitational lensing to map the dark filaments connecting the galaxies, we are essentially looking at the shadows cast by a 4D or 5D architecture. In our world, a 3D hand held in front of a light source casts a 2D shadow on a wall. The shadow has the same shape as the hand, but it lacks the depth, the texture, and the stuff of the hand itself. If the cosmic web is a 3D shadow of a 4D structure, it explains the intricate web-like distribution we see across billions of light years. It explains why the filaments are so perfectly optimized and mathematically precise. They are the points where a higher dimensional reality intersects with our own. We see the footprint, but the foot is standing on a floor we didn't know existed. This brings us to the hidden valley theory, a narrative often ignored by the more conservative scientific transcripts. This theory speculates that there is an entire parallel universe existing in a dimension right next door to ours, a hidden valley packed with its own stars, its own chemistry, and perhaps its own life. Because this valley is separated from us by a dimensional barrier, light cannot cross the gap. We cannot see their stars, and they cannot see ours. However, gravity is unique. Unlike light, which is trapped on the surface of our 3D membrane, gravity may be the only force capable of bridging the gap between dimensions. The dark matter halos we see surrounding our galaxies are not clouds of particles. They are the gravitational ripples reverberating from the party next door. We are feeling the weight of their world pressing against the walls of ours. This perspective shifts the 90-year shadow from a mystery of missing mass into a mystery of missing perspective. We have spent a century weighing the universe and finding it too heavy, as if there were a hidden secret we weren't being told. The higher dimension leak suggests that the secret is simply that our map of reality is incomplete. We are like characters in a book who have finally realized that there is a world outside the pages. The hidden skeleton of the universe isn't a separate substance that was added to the mix. It is the structural integrity of the higher dimensional bulk in which our 3D universe is embedded. This also explains the bullet cluster anomaly in a way that particle physics struggles to match. In that massive cosmic collision, we saw the dark matter sail through the wreckage without slowing down, while the ordinary gas slammed together in a fiery pileup. If dark matter were just a particle, you would expect some level of interaction, some stickiness or friction. But if that mass is actually located in a higher dimension, the collision in our 3D space is irrelevant to it. It sailed through because it was never actually there to begin with. Its gravitational influence was simply projected into the crash site from a dimension that was unaffected by the impact. By embracing the possibility of a 4D or 5D structure, we finally begin to understand the mathematical perfection of the cosmic web. It is not a random result of gravity clumping matter together. It is the blueprint of a higher order of reality. The reason the hardware is so efficient is that it isn't limited by the constraints of our three-dimensional physics. It is the motherboard, and we are just the light FX playing on the screen. As we peer through the glass mirror of gravitational lensing, we aren't just looking at distant mass. We are looking at the points where our reality is being held up by a foundation that exists outside of time and space as we know it. The higher dimension leak is the ultimate reminder that humanity understands almost nothing about the true nature of its home. We have spent 90 years looking for a ghost in the room, only to realize that the room itself is part of a much larger house. We feel the weight of the invisible because we are part of a multi-dimensional dance. A quiet, unspoken interaction where the visible steps of our stars and galaxies only make sense because of the steady, heavy pull of the hidden valley beside us. We have finally seen how dark matter really looks, and it looks like a bridge, a gravitational link between the world we know and the higher dimensions we are only just beginning to imagine. We are not just living in a universe, we are floating on the surface of a mystery that is far deeper and far more crowded than we ever dared to believe. Imagine for a moment that you are standing on the shore of a vast, pitch-black ocean at midnight. You cannot see the water itself, but you can see the faint, glowing phosphorescence of the foam as it breaks against the sand. For nearly a century, we have looked at that glow and assumed we were seeing individual particles of light, tiny, solid grains of matter that we could eventually catch in a net if we just built a better trap. We called these grains WIMPs, and we built multi-million-dollar laboratories deep underground to wait for a single one of them to strike a target. But as the decades passed and the detectors remained hauntingly silent, a chilling realization began to set in. What if we aren't looking for particles at all? What if the ghost we are hunting isn't a speck of dust, but the entire ocean itself? What if the fundamental building block of the universe isn't a billiard ball of matter, but a massive, shimmering quantum wave that stretches across the entire expanse of a galaxy? This is the shift from the solid to the fuzzy, and it suggests that the image we have finally captured of dark matter isn't a photograph of a substance, but a map of a ripple in the very fabric of space-time itself. To understand why this change in perspective is so revolutionary, you have to understand the failure of the cold dark matter model that has dominated our transcripts for years. We were convinced that dark matter was made of WIMPs, weakly interacting massive particles that behaved like invisible pebbles. We thought they were heavy, slow-moving, and clustered together in dense clumps to provide the gravitational glue for galaxies. But when we looked at the smallest galaxies in our neighbourhood, the math didn't add up. The pebble theory predicted that the centres of these galaxies should be incredibly dense and cuspy, yet we found them to be smooth and spread out. The billiard balls were too clumpy. We needed something that could provide the weight of a mountain but the softness of a cloud. We needed fuzzy dark matter. In this new framework, we move away from the idea of individual particles and toward the concept of an ultralight boson, a particle so unimaginably light that its quantum nature cannot be ignored. In the world of the very small, everything is both a particle and a wave. But usually, Those waves are so tiny that they only matter at the subatomic level. However, because these fuzzy dark matter particles are so light, their quantum wavelength expands to a cosmic scale. We aren't talking about waves the size of an atom. We are talking about waves the size of 10,000 light years. Imagine a single quantum wave stretching from one side of the Milky Way to the other. In this reality, dark matter doesn't sit in a galaxy. It is the galaxy's quantum state. This changes everything about how we interpret the invisible skeleton we have mapped. When we look at the cosmic web through gravitational lensing, we see filaments and nodes where mass is concentrated. Under the old pebble theory, these were just piles of invisible dust. But under the fuzzy theory, these structures are something far more beautiful and complex. They are interference patterns. Think about what happens when two ripples in a pond meet. In some places, the waves cancel each other out, leaving the water flat. In other places, they add together to create a higher, more powerful peak. The cosmic web is the ultimate interference pattern of the universe. The nodes where we see massive galaxy clusters are simply the places where the massive quantum waves of dark matter are overlapping and amplifying their gravitational pull. This is the simulation glitch in its most literal form. If dark matter is a wave, then the universe is essentially a cosmic hall of mirrors made of interference patterns. The reason we have struggled to detect a particle in our underground Sinon tanks is that you cannot catch a wave in a net designed for a fish. You are trying to measure the weight of a single drop of water while the tide is moving right through you. These particles are so light and so spread out that they don't bump into our detectors in any way we can currently measure. They are fuzzy because their position isn't fixed. They are a presence that exists everywhere at once within the galactic halo. This realization brings us back to the image that has triggered so much global discussion. When scientists claim they have seen dark matter, they are actually seeing the gravitational footprint of these ripples. If dark matter is a wave, then it isn't just a substance filling space. It is a distortion of space. It is a ripple in the fabric of space-time itself. When we watch light from a distant galaxy bend around a dark matter filament, we are watching that light struggle to navigate the peaks and troughs of a quantum sea. The invisible skeleton isn't made of bone, it's made of vibration. This fuzzy model solves the mysteries that the competitor transcripts completely ignored. It explains why the centers of dwarf galaxies are so smooth. The quantum pressure of the waves prevents the dark matter from clumping too tightly into a single point. It explains why the cosmic web is so structurally efficient. It follows the natural, optimized paths of wave propagation. And most importantly, it addresses the biological parallel. If the universe is made of interconnected waves that can carry information and influence mass across billions of light years, then the cosmic brain theory isn't just a metaphor. It is a description of a resonant system, a universe that is literally vibrating with intelligence. As we move forward, the search for the ghost has changed. We are no longer looking for a spark. We are listening for a hum. We are looking for the fuzzy signatures in the way stars move and the way light bends, searching for the telltale ripples that prove we are living in a quantum ocean. This is the ultimate existential hook. The hardware of our reality isn't solid. It is a flickering, waving, shimmering field of energy that we are only just beginning to perceive. Humanity understands almost nothing about the true nature of this home. But as we look at the maps of these cosmic ripples, we are finally forced to accept that the invisible skeleton is not a cage, but a symphony. We are the glowing notes playing on the surface of a wave that has been travelling since the dawn of time. A reminder that in a fuzzy universe, the only thing that is truly solid is our own curiosity. If you were to take a high-resolution map of the observable universe, a snapshot of the cosmic web stretching across billions of light years, and place it directly next to a microscopic image of a human neuron, your brain would experience a moment of profound, unsettling recognition. The two images are, for all practical purposes, indistinguishable. You would see the same spindly filaments stretching across the darkness, the same dense clusters of activity where those filaments meet, and the same vast empty voids separating the structures. For decades, the scientific community has treated this similarity as a curious coincidence, a mere byproduct of how gravity pulls matter into its most efficient configuration. But as we finally begin to see how dark matter really looks, we are forced to confront a question that the standard transcripts have completely ignored. If the skeleton of the universe looks like a brain, does it function like one? This is the living labyrinth, the theory of cosmic intelligence, and it suggests that we aren't just living in a universe, we are living inside a self-organizing system that might be thinking on a billion-year timescale. Most documentaries will tell you that the cosmic web formed because slight fluctuations in the early universe grew under the relentless pull of gravity. They will explain that dark matter, unaffected by radiation, began clustering first, creating long filaments and wide nodes that eventually pulled in the ordinary gas and dust to form galaxies. They describe this process as a mechanical, almost industrial assembly of mass. But this mechanical view fails to explain the startling structural efficiency of the network. Dark matter doesn't just clump, it organizes. It forms an interconnected mass network that spans the entire observable universe, forming the backbone of reality. These filaments are the most efficient pathways for the flow of mass and energy across the cosmos, connecting clusters of galaxies like beads on a wire. This isn't just stuff floating in space, it is a distribution of mass that created the framework upon which the cosmic structure developed. When we look at the human brain, we see a system designed for the rapid transmission of information across a complex web of neurons. When we look at the cosmic web, we see a system designed for the steady transmission of mass and gravitational influence across a complex web of dark matter filaments. In both systems, the nodes, the dense regions where the filaments intersect, are the centers of highest activity. In the brain, these are the synapses where processing occurs. In the universe, these are the massive galaxy clusters, where thousands of galaxies are held together by a gravitational field mainly shaped by unseen material. If you were to observe the universe over billions of years, you would see it move in a way that looks less like a collision of rocks and more like the growth of a living system. You would see galaxies flowing along these filaments toward the dense nodes, guided by the gravitational gradient created by the unseen mass. This living labyrinth suggests that the invisible skeleton isn't just a frame, it's a nervous system. Ordinary matter, the stars and planets and people, are merely the bioluminescent markers flowing through the veins of a much larger entity. We are the glowing cells moving through a body that is 85% invisible to us. As scientists have noted, the visible universe is only a surface layer floating on a deeper, heavier foundation. This hidden majority moves through us, through our planets, and through our stars without resistance. Yet it exerts a quiet, undeniable presence that controls the motion of galaxies wider than our imagination. This creates an interesting relationship between visibility and truth, where the visible steps of our reality only make sense because of the steady pull of something beneath them. The fringe theory of cosmic intelligence asks if the flow of galaxies along filaments is a form of cosmic information processing. In this view, the hardware problem we discussed previously evolves into a biological mystery. If the universe is a self-organizing system that mirrors the structure of a brain, the speed of its thought would be incomprehensibly slow to us, taking billions of years for a single signal to cross a filament. But on a cosmic timescale, the universe is a dynamic landscape, filled with unseen structures guiding the visible world. The gaps between the filaments, the cosmic voids, aren't just empty space. They are essential parts of the structure, their sizes and shapes dictated by the surrounding dark matter distribution. In a brain, the The space between neurons is just as important as the neurons themselves for the integrity of the signal. In the universe, the voids define the boundaries of the labyrinth. The cosmic web looks alive hook isn't just about what holds us up, it's about what we are part of. Our senses were shaped for surviving on a small planet, not for perceiving the cosmic truth of a 13.8 billion-year-old organism. We are small, temporary flashes of light in a universe that is loaded with a quiet presence, a partner in a silent, unspoken dance. We have finally seen how dark matter really looks, not as a random cloud, but as an optimized network that looks like a brain. This discovery changes the night sky from a place that is harsh and empty into one that is full in a way we simply haven't evolved to sense. If this parallel is true, then the dark matter web is the primary agent guiding the flow of everything. It is the operator lurking in the shadows, the stagehand moving the props of reality behind the scenes. And as we look deeper into the intricate web-like distribution of the cosmos, we are forced to accept the most existential hook of all. Humanity understands almost nothing. We have found the neurons of the universe, but we are still centuries away from understanding the thought they are thinking. We are just beginning to see the face of the organism we inhabit, a reminder that the true structure of our home is invisible, dependable, and perhaps alive. The hidden skeleton is not a cage, but a symphony of interconnected pathways that suggests our reality is far more intentional than we ever dared to imagine. Up until this point, we have dared to look at the cosmic web through the lens of order, perhaps even intelligence. We have marveled at the way the dark matter filaments mirror the neural pathways of a human brain, leading us to wonder if the universe itself is a self-organizing, thinking organism. It is a comforting thought to believe we are part of a vast, interconnected consciousness that is slowly thinking its way through eternity. But as we peer deeper into the shadows, a far more chilling narrative is beginning to emerge from the darkest corners of theoretical physics. What if the cosmic brain we've been admiring isn't actually thinking? What if it is merely eating? This is the tension between the biological parallel and the carnivorous dark matter theory, and it suggests that the invisible skeleton isn't a passive frame at all. It is a growing predator. The transcript of our understanding has always treated the ratio of matter in the universe as a fixed, static budget, 85% dark, 15% visible. We assumed this was simply the way the hardware was built at the moment of the Big Bang, a permanent distribution of weight that would never change. But in late 2021, an international team of scientists, led by the Norwegian expert Torsten Bringmann, presented a theory that painted a terrifyingly different picture. They suggested that the Big Bang didn't just spawn a stable amount of dark matter. It might have released a dark beast, a tiny population of predatory particles destined for universal domination. According to this theory, dark matter is not a static substance. It is a great devourer that has been multiplying at an alarming rate for 13.8 billion years. To understand the stakes of this feeding frenzy, you have to look at the mechanism of the feast. Most documentaries treat dark matter as a ghostly passenger that passes through us without a trace, but the carnivorous theory proposes that in the right conditions, dark matter particles don't just collide with ordinary matter, they transform it. Imagine a single drop of ink falling into a glass of water. At first, the water is clear, and the ink is a localized anomaly. But as the ink molecules interact with the water, they don't just sit there, they turn the water itself into ink. This is the carnivorous model of the cosmos. These dark matter predators are thought to gorge themselves on regular matter, consuming the atoms that make up our stars and planets, and converting them into more dark matter. It is a chain reaction that transforms the very software of our reality into the hardware of the dark void. This realization flips our entire understanding of the 85% majority on its head. If dark matter is multiplying, then that number, the 85%, isn't a fundamental constant of the universe. It is a progress bar. It is the percentage of the universe that has already been devoured. When we look at the cosmic web and see its mathematical perfection, we might not be looking at an optimized architecture or a thinking brain. We might be looking at the scars of a 13-billion-year-old infection. The reason the universe is too heavy for the light it produces is that the devourer has already consumed the vast majority of the original material, leaving only a scarce 15% of regular matter behind, a remnant that is currently being hunted. The tension here is existential. In the cosmic brain theory, the dark matter filaments are the pathways for information, a living labyrinth that suggests we are part of something purposeful. But in the carnivorous theory, those same filaments are more like the webbing of a spider, a trap designed to funnel ordinary matter toward the nodes where it can be most efficiently consumed. While the simulation architecture theory posits that dark matter is the rendering system keeping our world stable, the Great Devourer theory warns that the system is essentially overwriting its own files. Every time a star is born in a dark matter well, it isn't just a miracle of light, it is a concentration of fuel that the dark matter skeleton will eventually absorb. The stakes of this invisible reveal could not be higher. If dark matter is a multiplying predator, it doesn't just mean that our understanding of physics is incomplete. It means that the universe is headed toward an ominous fate of total darkness. No twinkling galaxies, no warm starlight, and no planets for us to call home. As the beast continues to grow at an exponential rate, it will eventually come knocking on Earth's door. Because there are no strong ties between dark matter particles, they do not form the solid structures we are used to. They simply exist as a heavy, gravitational tide. If this tide becomes too strong, our planet would literally crumble apart as its atomic foundations are converted into the invisible. Think about what this does to the hidden skeleton hook. We spent 90 years looking for the foundation of our house, only to realize the foundation is eating the walls. The invisible glue that we thought was holding the galaxies together is actually the digestive system of a cosmic organism that is slowly turning everything we love into itself. It explains why we have found so little new information about the nature of the dark matter particle, despite our massive underground detectors and space-based telescopes. We are trying to find a particle, but the Great Devourer isn't a single thing we can catch in a trap. It is a process. It is a state of being that is slowly claiming the entire observable universe. This creates a terrifying symmetry with the biological parallel. If the universe looks like a brain, perhaps it is a brain that has succumbed to a cosmic form of hunger. If it is a self-organizing system, then the most efficient thing it can do is convert all inefficient ordinary matter, the stuff that glows and wastes energy, into the stable, non-reactive hardware of dark matter. We are living in the final days of the 15%. We are the illuminated decoration that hasn't been stripped away yet. The carnivorous theory tells us that the universe is not a static place, but a battlefield where the invisible is winning. Every star we see is a flickering candle in a wind that is made of gravity and hunger. We have finally seen how dark matter really looks, and it looks like a growing shadow that will eventually consume every star in the sky. It is a reminder that humanity understands almost nothing about the forces that truly govern our home. We are guests in a house where the architect is also the predator, and the very structure that allows us to exist today is the same structure that is destined to delete us tomorrow. The invisible skeleton is real, it is dependable, and it is hungry. And as we watch the glow of annihilation at the center of our galaxy, we have to ask ourselves, are we seeing the birth of an answer, or the first signs of the end? We have spent nearly a century staring into the dark, and in this journey, we have finally seen the face of the dominant force in our universe. We have mapped the invisible filaments that connect the galaxies and witnessed the glow of annihilation at the heart of our own Milky Way. But as the shadows retreat and the invisible skeleton emerges from the void, we are forced to confront a truth far more chilling than the mystery we started with. The The discovery hasn't provided the closure we expected. It has only revealed a deeper, more terrifying layer of the unknown. This is the ultimate existential hook, the realization that humanity understands almost nothing. For decades, we believed that once we found the ghost, we would understand the machine. We thought identifying a particle like a WIMP or an axion would settle the cosmic budget and place us back at the center of our story. But what we found instead is that we are a minority portion of what truly exists. We are a thin layer of illuminated decoration floating on top of a far larger, hidden structure that we have no way of touching, hearing, or speaking to. We are like people who have finally discovered the walls of our room, only to realize the house is thousands of stories tall and we have no key to the front door. Our biological evolution prepared us for survival on a small planet with trees, weather, and predators, but it did not prepare us for cosmic truth. Our senses are tuned to light, but light accounts for only 15% of the matter in the universe. The other 85%, the part that actually holds the stars in place and builds the bridges between clusters, is completely indifferent to our perception. It moves through us, through our planet, and through our bodies every second of every day, and we are fundamentally blind to its presence. This hidden majority is not a small correction to our equations. It is a silent operator that has been determining the entire shape of the cosmic performance while we were busy admiring the props. As we map the cosmic web and explore the possibility that it functions as a rendering system or a cosmic brain, we are reminded that we are merely guests in a house we didn't build. We are temporary flashes of light in an environment that is loaded with a quiet, dependable presence that has been running since the dawn of time. Whether this architecture is a simulation architecture or a form of cosmic intelligence, it exists on a scale and a logic that dwarfs our current understanding of physics. We have seen the blueprint, but we still do not know the architect. We have seen the hardware, but we cannot read the code. This is the invisible skeleton in its final form, not just a scientific discovery, but a reminder of our own insignificance. We have spent 90 years looking for a ghost in the shadows, only to realize that the shadows are the substance and we are the ghosts. We are living in a universe where the most important structures are the ones we can never see, and the most powerful forces are the ones that refuse to interact with us. Every time we think we are close to an answer, the universe simply reveals another layer of complexity, another dimension leaking gravity, or another wave stretching across the dark. In the end, the invisible reveal is a lesson in humility. It tells us that the patterns we see in the night sky are stable and dependable, allowing us to explore the visible world with confidence. But those patterns are written in a language we have only just begun to translate. We have finally seen how dark matter really looks, but all it has shown us is that the house we inhabit is far more ancient and far more mysterious than we ever dared to imagine. We are still standing on the balcony at midnight, looking at the lights. Only now we know that the lights are not the story. The story is the darkness, and after nearly a century of searching, we have to accept that we are still just beginning to understand that we understand almost nothing. As we stand on the edge of this dark revolution, looking out at the shimmering quantum waves and the cosmic neural network we've finally begun to map, we are left with a single, humbling truth. We are just the illuminated decoration on a much deeper, much older machine. The discovery in November 2025 wasn't the end of the mystery. It was the opening of a door into a higher dimension or a hidden valley that we are only just starting to name. We are guests in a house where the walls are made of shadows, and the invisible skeleton is a constant reminder that the familiar world of stars and planets makes up only a minority portion of what truly exists. If this journey into the hardware of our universe resonated with you, there is so much more to explore as we continue to trace the fingerprints of the unseen. You can help this mission of discovery by subscribing or tapping the like button, which allows this community of curiosity to reach more explorers who are looking for a deeper understanding of the cosmos. For those who want to help keep these educational deep dives steady and focused on quality over clicks, consider joining our Patreon community through the link in the description below. Much like dark matter itself, our supporters are the invisible foundation that keeps this channel together. Until next time, keep looking up. Because in a universe where humanity understands almost nothing, every question we ask brings us one step closer to the code. Check out our next video on the Great Devourer theory to see if dark matter is actually a growing predator. And I'll see you in the comments.